I'm gonna go ham on the practice test. Okay, so let's do this. All right, so example 3. Approximate to the nearest hundredth the relative or absolute extrema of each function. State the x values where they occur. So all you have to do for this one is, all right, so I'm gonna come over here to my handy dandy calculator. Go to my calculator. Oh, why is this not bigger? And I'm going to insert the equation. So negative x to the third minus x squared plus 2x minus 1. Ah, no. Ah, of course. How are you guys today?
Good, how are you?
I'll be better in a moment. Okay. Wow. 2x. That was a crazy graph. That's much better. Something to the third power should look like this. Or if you have negative in front of it. Ready? There you go. Oh, that's what it looks like. Perfect. Nailed it. So I need to find the extrema. So keep in mind the difference between a minimum and a maximum. You have to have a critical point. A point where you are switching from increasing to decreasing, or decreasing to increasing, or constant. Like you're switching what you're doing. Either you're increasing, decreasing, or staying the same. So I see, can you see what's happening right here? I'm switching from going down to going up. So that's going to be a 50-50 shot. It's either min or max. This right here is a min. Is it a relative min or an absolute min? So people are saying it's absolute. This is the lowest the function goes. It stops right here and goes up forever, right? Oh, it's actually not absolute because look, there's y values that are smaller. This is only a relative min. How would I go about finding the actual value of this minimum? Menu. Analyze graph. Minimum. Okay. Cool. Menu. Analyze graph. I'm looking at the relative min. So this is not something I could have you do without a calculator. So the relative min occurs at negative 1.22, comma negative 3.11. And it says approximate to the nearest hundredth. So the nearest hundredth is 2 decimal places. Hundredth is like cash money. You want all the cents you can get. It's 2 decimal places. Tenth is 1 decimal place. Awesome. Because then if I specify in the directions, I'm expecting you to follow the directions. If you do not round properly, just like a minus sign, it's like a little bit off. Not a lot, just a little bit.
Do we only say the x value or what?
So I'm specifying the exact point. That is my critical point because that's where I'm switching from decreasing to increasing. That is where it occurs. So at negative 1.22, my x value, my y will have a negative 3.11 value, and that is where my minimum occurs. And it's only a relative. There is no absolute min. Okay, now let's talk about maxi boy, all right? So look at this maximum right here. You see right here? Can you see where I'm pointing? Trying to make it a little clear. Right there. So around it, just generally around it, it's like a little mountain. It's a little hill. You're at the top of a little mountain. So if you drive on the 101 coming from Calabasas, right? Between here and I think it's Lost Hill. You know what I'm talking about? Like there's the 101 goes up this hill. Okay, so I go up to a maximum, but that's not the max, right? Because the 101 goes like up higher mountains or something, I bet. But that's a local. So if I'm only looking at this small area around it, this is a local maximum, sorry. It's a relative maximum because it's higher than everything around it, but it's not the highest because notice right here, my function value goes higher. So it's not the absolute because it's not the highest of the whole domain. It's only the highest in the place around it. And if I had like 50 bumps, oh my gosh, I could literally list out all of the relative min and max, right? So 50 bumps, do you see how I'm doing this? Lots and lots of ways. I could have a million relative mins, a million relative maxes, only one min, absolute, only one absolute max. Only one can be absolute, only one can be king.
For relative, you list as many as there
Yeah. Yep. Because it wants the near, yeah. Okay, so I had to read the directions. So I'm looking for the max menu, analyze graph, go to maximum. So I'm just gonna go roughly around it, and it finds my maximum. So my relative max is gonna occur at 0.55, comma, negative 0.37. Because it says to nearest hundredth, so we must follow the directions. And that's relative max. Give a shot to B, see if you can solve B. Oh, wait, so I should write there's no absolute max. And remember, there's no absolute min or max because this min I found, it's not the smallest my y goes. This maximum I found, it's not the highest my y goes. Okay, so try out B, see if you can practice little keystrokes. So I'm gonna do it and I'll write it on the board. Oops. Minus 2x plus 4. Sorry, what? So in this case, one of our relative minimum will be the absolute min. So we're going to write all of our relative mins and maxes. So in this case, we can talk about the end behavior.
Wait, so is the relative min just all of the minimums?
Yes. But the absolute min is like, hey, for all of my x's, this is the absolute lowest my y goes.
Do you connect it by union or is it like comma?
No, you just like listed all the points. Okay, so it actually, wow, it has one of the minimums for me. Didn't realize I'd do that. Let's find the mins first. So I see I have two minimums, two relative minimums. Relative just means, of the things around it, this is the lowest the y goes. And of my two minimums, one of them is actually the lowest the whole function goes. All right, so hopefully you can see the graph is going up as x gets more negative. The graph is going up as x gets more positive. So the lowest the graph actually goes is a negative 5.51. So I have two relative minimums. One is at 1.47. Why is this doing this? Okay. Comma 0.81. My other relative min is at 1.67, comma negative 5.51. And I can be specific and say this is my absolute min. I can specify, because although both of these are my relative, the bottom one that I wrote is my absolute. Will I have an absolute maximum? No. But I do have one relative max. Menu, analyze graph, maximum. But I do have one relative max. And this is occurring at negative 0.20, comma 4.2. No absolute max. Because, I don't know why I did this. No absolute max. And the reason is because even though this is a local max, there are y values that are higher than it. Oh, you're done? Thank you. Cool. Did you say you have soccer?
Yeah.
Good luck.
Thank you.
Okay, so questions over this one? No? I mean, I think I've beat it into your brain. Optimization's like, oh hey, so you're literally finding the minimum and maximum, but nah. And then this is the last part. So I don't think we'll be surprised to find the average rate of change is literally the slope between 2 points. It's more or less the average. So notice I have this curve graph right here. And if I connect 2 points and draw a line between them, my line is crossing my graph at 2 points. So coming from geometry, do you remember a chord that touches a circle at 2 points is called a secant? Yeah. Surprise, it's right here, if you only looked ahead. Geometry. The line through 2 points on a curve is called a secant line. The slope of the secant line is, m secant. Which slope? Oh, the secant one. The one that, it's like a, what is it? Subtext? No. Subscript. It's a subscript. We're saying which slope? Oh, the one that is the secant slope. So average rate of change. So we're like throwing in all of these like key concepts of calculus, but like kind of like making it a little simpler. So next year you're going to see this and you'll be like, yes, I remember learning it. Guarantee if you ask Noah, who was in here just now, he'll be like, oh yeah, we learned this and then we went even further in calc this year. So average rate of change is the simplest way to find a rate of change. And this is the average rate of change. You're taking how much you start with, how much you end with, and finding the average between it, finding the slope between them. Okay, so, because it's not exactly like, if I look, the slope of this line is positive right here. The slope of this line is negative. So if you're trying to find the average slope, I mean, more or less that's what we're doing. Anyway, it is the equation of slope. y1 minus y2 over x2 minus x1. Except here it says f of x2. Well, you know f of x is the same thing as saying y. So if I'm saying f of x2, I'm just saying, oh, that's y2. Literally just slope equation. All right. Find the average rate of change of the function f of x equals negative 2x squared plus 4x plus 6 on each interval. So I know the slope is going to be f of x2 minus f of x1 all over x2 minus x1. Let me zoom in a little more for this. It's okay. Well, first I need to know what is f of my second function. Do we know? So I have to plug in. So this is my x1, this is my x2, because I'm saying over this interval, what's the average rate of change? So you just use the two endpoints. We're using our two endpoints. These are my two x endpoints, and I have to find what the y values are. So the slope of my secant line is going to be, let's see, I have to plug in x2 into my equation. So I have negative 2, negative 1 squared plus 4 times negative 1 plus 6. So I'm right here. Plugging negative 1 into this equation. Okay, that's f of x2 minus f of x1. So negative 2 times negative 3 squared plus 4 times negative 3 plus 6 all over negative 1 minus negative 3. This portion right here is f of x2. This portion right here, f of x1. So I have 1, so this is negative 2 minus 4 plus 6 minus, let's see, 9, negative 18 minus 12 plus 6 all over negative 1 plus 3 all over 2. So of course, if you have a calculator, you could just like plug it in and find it. Negative 2 minus 4, negative 6, 0 minus, for the answer? Let me figure this out. Negative 30, negative 24, so 24 over 2 is 12, yeah. How do you feel about this? Yeah, I mean, I think it's pretty straightforward. It's just we're not. If it was a line, an actual line, this would be the slope of the line. But of course, if we have a bunch of like curves and stuff, I could find the average rate of change by just more or less making a secant line through whatever two endpoints is. Yes.
We always give us this numbers, or do we have to find it on a graph?
You may have to find it on a graph.
But it doesn't matter which ones. Or the
Well, I will give you the 2 because if I want the average rate of change in like the first 2 seconds, oh, that's from 0 to 2. So 0 is your first, 2 is your second. I didn't realize how big I was writing, so. Do you guys feel confident in this? Do you want to do the second example? No? Okay, it's literally just using slope equation. You just have to find the y value for each of your x's. Okay, so now that we've done this, we can go through the practice test. No, people said no, and that's what I heard. So, yeah. Come on. Okay. So, y-intercept. How do you find a y-intercept? When x is equal to 0. So you set x equal to 0. So you have 0 cubed plus 6 over 3. That's just going to be 2. But of course, it needs to be in the intercepts are points, not lines. So you have to have x comma y.
It's 6 over 2.
Yeah, 6 over, sorry, 2 is 3. Let's put the numbers in the wrong space. Okay, so 3. So 0 comma 3 is your intercept. What if I wanted the x-intercepts? You set y equal to 0. And so I would say 0 equals x cubed plus 6 all over 2. How would you get this by itself? Huh? Yeah, I could multiply both sides by 2. So 0 times 2 is 0. X cubed, let's see. So I have 0 equals x cubed plus 6, subtract 6. So it'd be the cube root of 6. There'd only be one intercept. So it'd literally be cube root of 6 comma 0 would be your x-intercept. So on the actual test, there's a question where I ask for both. All right. Domain and range of the functions shown on the graph.
Wait, why isn't it negative?
Sorry, it'd be negative. Yeah, cube root of negative 6. I'm sorry. Yeah. Okay. Cool. Domain and range of the function shown on the graph. So, if I want domain, that deals with the x. So it's like I'm going to take this graph and smush it vertically. So I just want to make a one-dimension number line. Oh, let's see. So then I have a closed circle to open right here. And then I have an open circle on to infinity. So if I could simplify this, if any parts overlap, I can just combine them all into one number line. So first, I'm a visual learner. So I'm trying to see where x is actually defined. So I just took all of my open and closed circles and made them into one dimension. So I'm only caring about x, not y. So I'm only looking at domain right now. So if I would redraw this, let's say I have an open circle. So although x is not defined right here, it's defined down there. So I do have a y value when x is negative 1. So I'm going to close that in. What about at x equals 2? No, I don't actually have a y value, and then it goes on forever into the right direction. So this whole closed circle business, right here, the closed circle, cool. It's part of the line that I drew. I don't actually have to stop at that point. What I mean by that, if I would write out the domain, I would start at 1, 2, 3, 4, negative 5. Not include negative 5 because it's an open circle. And I go all the way to 2. union, because I don't want to include 2, because there's an open circle, there's a hole. If I say, what is the y value for 2? There is no y value, it's undefined. There's no filled circle for an x equals 2. And then 2 to infinity. That's what the domain would be. Why did I not go -5 to -1? Why did I not have -1 as part of this? Ellie, do you know? Exactly, it overlaps. I have a y value. It's not the first part up above. I like to drop down to the next part of my function. Okay. So there's, let's see, 2. Try to like talk about the test as we go through it. So there's 2 questions similar to number 1. One of them asks for the zeros of the function. The other asks for the x and y intercepts. What does it mean to find a 0? The x-intercepts. Okay, cool. So there's 2 questions like that. There's 2 questions like number 2 and like number 2. So let's go over number 2. Let's finish it. Find the range. 10 questions total. And there's a bonus. Okay, so if I'm dealing with range, let me get a different color. I'm dealing with range. So instead of smushing it vertically, it's like I'm going to vertically just like make it into 1 dimension number line. So I see at -4, I have a y value -4. Notice it's not at -3.9 or 4.1. Literally, that line is horizontal. It's only at y of -4. I have an open circle, and it goes up forever. So more or less, what this number line is showing you is where y is defined. So I'm saying, okay, well, where is y equal to 0? Oh, right here. Where is y equal to -1? Right here. Where is y equal to 4? Okay, right here and all along here. Where is y equal to -3? Let's see, -1, 2, 3. It's not. There are no y values for -3. Where is y equal to -4? Oh, right along this line. Where is y equal to -4.1? Nowhere. There's nowhere. Y is not defined right here. It's not part of any of my graphs.
Even if the one to the top left was closed circle, it would still be the same.
Yeah, because it's already included. It's already included within.
And if it's a filled circle, does that mean it's bracket for this case as well?
Yes. So this is a interesting case because I have to include -4, but I only want to include -4. I don't actually have an interval. I only want to include the one number. So you just have a square bracket around it. And then I want a union and go from -2 to infinity. There are questions about this one? Yes.
Where'd you get the number from?
So -1, 2, 3, 4, 5. So this is starts at x value -5. Here's counted on my graph. Yep. Wait, did that answer your question? Okay. Yeah.
For the range, if it for the one that's horizontal, but at the bottom, if it was a open circle, would it still?
It doesn't change it because I'm only talking about the y.
Okay.
Yep. Yes.
Can you explain your diagram for me?
What is the y value of this right here? -4. It's 4 down. It's almost like if I could take this graph and just only make it into 1 dimension y number line. Because I don't really care about like how it's moving horizontally, like x, y. Okay, with the range, I only want to know where is y defined. Where do I have that y value? There is nowhere, like if you look at this graph, I could be like, oh, where is y equal to -6? It's not. There's nowhere where you can point and be like, here's where y equals -6. If I ask you where is y equal to -3.9, it's not. There's nowhere where it's actually equal to -3.9. This horizontal line, it's like, oh, there's a bunch of places where y is equal to -4. And then there's a place where y is, then all the numbers greater than -2, you have a place where y is equal to it. I think there's another one, yeah, down here. It's like more practice below. All right, use a graph to find indicated values. So let's find the value of 0. What is the value of 0? The function value of 0. 0, it's right here. What is the function value of 2? 6. So that's a tricky trick part because I have an open circle. You have to find where it's closed. If I did not have that closed circle right there, it would be undefined. And what about the y value
It would be undefined and
if there was not a closed circle function? Undefined. If I don't have a limit, you say it doesn't exist. If you don't have a function value, you say it's undefined. So no function value, undefined. If you don't have a limit, you say it does not exist. All right, and f of 6. So 6, 1, 2, 3, 4, 5, 6. So it's right here. 1, 2, 3, 1, 2, 3, 4. Ah, that was boring. I actually gave you they all have a function value.
So if we don't have
No f of x value, no y value, you say undefined. No limit, you say it does not exist. Okay, so number 4 deals with this graph up here. Sorry that I didn't put it on the same page. I was like kind of trying to save some paper by putting it all together. On your test, I space things out, so you have plenty of room to show all your work. So if I'm looking for the limit as x approaches 0, right? So as I get close to 0. So as I get closer and closer to an x value of 0, what is my y approaching? 0. And I'm approaching that same number from both sides. So I say 0. All right, now I'm approaching 2. Okay, so now I'm approaching 2. As I approach 2, right, here's x equals 2. So as I get closer and closer from the left side, it seems like the y value would be, now let's see, 1, 2, 3, 4. So what I mean is, you do not see all of this. You are coming from the left side, and you're going to assume what should your y value be. Can you read 4? It's kind of like you're driving on a road. Okay, you see the road in front of you. You don't expect all of a sudden a cliff, right? You assume, oh, I see a road. I assume I keep having a road, not just a random cliff or something. So you're trying to make an educated guess. What number are we approaching? 4 from the left side. What about from the right side? What am I approaching? 8. So the thing with limits is you have to approach the same number from both sides. So it does not exist. Because one of the sides is 8, the other is 4. Those are not equal, so we say it does not exist.
What if there wasn't anything on the right to indicate where it's
Anything on the right?
never mind.
Okay. And then here's my end behavior as x approaches negative infinity. All right, so as we're approaching negative infinity, so I'm coming up here, and I'm trying to go this way with my x's. What's happening to y? As I go left, what's happening to my y? It's going to positive infinity. So we write positive infinity, comma, does not exist. So you have to say DNE whenever you write infinity for your limits. 2 reasons. If I only wrote DNE, I would have no idea what is going on. Are we not approaching the same number? Like, I don't know. But by saying infinity, it's like, okay, I know what's happening to the graph. It's going, like Buzz Lightyear said, up, to infinity and beyond. It's going to infinity, up to positive. But technically, that's not a number you can point to on a number line. So that's why we say it does not exist. And end behavior. Yep.
Are we gonna have to know like the types of numbers?
Types of numbers.
Like it was on the practice test for the quiz. So like rational, real, full.
I don't think it was on the quiz.
It wasn't, but it was on the practice.
Yeah. No. There's more important things to memorize. Like limit notation. How do you write limit notation? You have to write in limit notation on the test or you get points off. No more of that funky algebra 2 stuff. X arrow, Y arrow. No. Limit notation. It must be limit of f of x as x goes to infinity. The other one is limit of f of x as x goes to negative infinity. Ah, wonderful. There are 2 questions like number 5 on there. Yay. telling you all total 10. So relatively short. There's a bonus problem. 7. Yeah. Okay, let's talk about the end behavior. So as x is going to the right, what's happening to my y? Wow, it's going up. All right, so it's going to infinity, comma, does not exist. Try out the second part. As x is going to the left towards negative infinity, what's happening to my y? Also going to negative infinity, comma, does not exist. So you have to specify, you have to have both. You have to have both. If you only have one part of it, you only get part of your points.
They can approach different things, right?
Yeah, my end behavior?
Yeah.
My ends, yeah. They could be, because what, ready? What does x squared look like? Oh, one more time. What's x squared look like? Okay, a bunch of bombs. Let's all try it. Ready? 2 arms. 2 arms. Let's go. X squared. What's the end behavior of x squared? They both are going to infinity. How about x to the third? End behavior. One's going to infinity, one's going to negative. Negative x squared. They're both going to negative infinity. Yeah, okay. So they can go the same way. They can go opposite ways. Whatever. What? You won't forget it, okay? I'll make a fool of myself all day if you get hundreds on your test. There you go. Here we go. So, there's 2 questions like this one. And then, no surprise, there's 2 questions like, okay, let me rewind a second. This number 3 and number 4 is number 9 and 10 on your test. Like, one of the questions is like, find 3 of these function values. Another question is, find 3 of these limits. So I think that adds up to 10. Okay, so let's go over number 6. Now, it is 100% possible to do this without a calculator. 100% possible. And I'm going to show you how. So, determine whether the function is continuous at the given x values. Justify using the discontinuity test. On the test, I literally specify, let me read you what I put. Determine whether the function is continuous at each of the given points. You must justify using the discontinuity test. Each of the 3 steps need to be shown. Okay. So you have to show all 3 steps. There's points associated with all 3 steps. This is how I made the test so short, is literally, this problem is worth 8 points. Normally your tests are out of 40. This is 1/5 of your test. The reason is because there's 2 different numbers to do. I am telling you exactly how I do this. So, at x equals -1. So there's 3 steps associated with finding discontinuity, and then there's 1 point for saying what type of discontinuity, or if it's continuous. 4 points for x equals -1, 4 points for the x equals -2. Does that make sense? There's literally a whole point for every single step. You have to show your work. I don't know how to say this more clear. You don't show all 3 steps, you're going to get points off. Okay, I'm done. I feel like a war veteran. I'm like, oh, it was so bad. I'm telling you the stories, and then people are not going to show their work, and I'm going to be so sad. I'm going to have to take off points. Okay, let's try it for the x equals -1 first. So, first step, find the function. What? Oh, -1. Find the function value. So, I'm going to plug it in. Because maybe I'll be the devil reincarnated and give you a point where it's actually continuous. You don't know. Maybe it'll be continuous. Maybe it'll be a place where I have discontinuity. Who knows? Okay. -1 squared plus 3. So for the function value, you want to actually plug it into the function. And then I'm going to show the next step in a moment. It's because I haven't showed the majority of people. So I get 0 over 0. Weird. So, okay, well, I mean, this isn't an actual number. It's indeterminate form. Maybe you don't remember me saying that. But this doesn't give me a number. What's important is the whole dividing by 0 means it's undefined. So f of negative 1, undefined. So I showed you guys this trick when we were going over section 3, what I'm about to do. So when you're finding the function value, plug into the function the way it is written. But this next part, the limit. Now, if you didn't have a calculator, you'd have no idea what this is approaching. So what we're going to do is see this bottom of my fraction, it's a quadratic. What would happen if I factored it? How do I factor?
X plus 2, X plus 1.
X plus 2, X plus 1. Wait, what the heck? I have an X plus 1 on top and bottom. So whenever you have a factor on the top and bottom that cancels, that is where you'll have a hole. Whichever factors don't cancel and remain on the bottom, those are your infinite discontinuities. So I'm going to say this again. I'll say it again. So I fully factored. Now, the solution associated with the factor that cancels is where your hole occurs. So if I set x plus 1 equal to 0, what is the solution? Negative 1. So this tells me at x equals negative 1, I'll have a removable discontinuity. What about this other one, right? So if I rewrite, my simplified function, so this is literally the function of 1 over x plus 2, but x cannot equal negative 1, right? This guy right here. Sorry, it's a little smushed. So literally, what is this graph going to look like? Oh, the graph of 1 over x plus 2. But what's going to happen at negative 1? Hole. It's just a removable discontinuity. If you can remove the factor from top and bottom by canceling it out, that's your removable discontinuity. That's where you're just like going along your function. And then, hole, just plucked out that one y value, and then you just keep going on with your function. Versus an infinite discontinuity. So if you factor the top and bottom, nothing cancels. All the factors on bottom, the solutions to the factors at bottom are where your infinite discontinuities occur. The solutions to the factors on your bottom of your function, bottom of your rational function, that's where your infinite discontinuities will occur. So when I'm trying to find the limit, what I said was, wait, after I crossed out my functions, I have this new function, my simplified function, the one I circled in the cloudy squiggle. That's more or less what the function's going to look like, except at x equals negative 1, I just have a little hole. So the second step of my continuity test, just a moment, I'm finding the limit of my function as x approaches negative 1. This is where you want to plug in your simplified function. You plug in negative 1 to your simplified function, it will tell you what y would be if it actually existed. If I didn't have a stupid hole. Okay, so limit of f of x, so it's 1 over negative 1 plus 2. So it's just negative 1 over, 1 over negative 1. So that's negative 1. So I have a limit.
Isn't it just 1? It's negative 1 plus 2 is 1.
You're right, I'm sorry. I think...
What if it doesn't simplify? What if...
Then all of your factors on bottom, you would have no... Okay, if it doesn't simplify, there's no removable. All of the factors on the bottom are where infinite discontinuities occur. All right, so the third step, literally my function's undefined. So clearly, f of negative 1 is not equal to the limit of my function as x approaches negative 1. So it's not continuous. Do we know what type of discontinuity? It's removable, because this is the solution associated with the factor that canceled out.
So it's whatever answer you get here is what your removable is, not like what's given.
Repeat the question.
Like if you get for 3, let's just say it's negative 2. How is your whole for this or for this? For this approach. Like, if you have a hole at negative.
So if I was gonna graph this, I know exactly where to put my hole. It would be at -1, 1. So if I wanted to graph this function, no, I don't have much room. So at -1, 1, which is about like right here, that's where I'd have a hole.
Let's just say like the hole is -3 in this case, and like where would you put removable? There wouldn't be one.
What?
Like, let's just say the hole is like -3, there you wouldn't write removable.
Hole is -3.
The hole.
So the solution to the factor that canceled out would be -3. So it'd be like the x plus 3 would have canceled. Wait, I'm sorry. What is your question? I'm sorry.
Like, if you have like a hole at -3, you wouldn't write removable for -1, -2.
It might be removable. Because imagine if I had a function like this. So we would have a removable at the x minus 2. We would have removable at x minus 3. But since this didn't cancel, right? So the solution to the factors that don't cancel are where your infinite occur. So what would the solution be if I set x plus 4 equal to 0? At x equals -4, it's an infinite. Because then, if it doesn't cancel, and I plug in -4, I would be dividing by 0. When you're dividing by 0, infinite discontinuity. But because I have these factors that do cancel, that's where your removable occur. So I'd have removable at -2 and at -3. Huh?
You would also have x.
Well, the x plus 1 does nothing. It's just a thing on top. Yeah. Okay, question.
So since you have both the removal and the infinite discontinuity.
Are you going back to number 6?
Yeah.
Okay.
Like, how do you know which to put if it's both of them? Like,
So at -2, we're going to have an infinite discontinuity. Do you know how I know?
This is a hole.
Because this is left over. The x plus 2, it's still there. It didn't go away. So if I set my bottom equal to 0, the x plus 2, if I would solve it, remember how we set each factor equal to 0? At x, if I put in -2, I mean, you'll see. Let's go through this. So my function value of -2, I'll get to in a moment. I plug it into the actual function. We started at the beginning. -2 squared plus 3 times -2 plus 2. I get a number. I get like -1 over 0, so that's undefined. But notice it's a little different than the 0 over 0. 100%, anytime you have a removable and you try to figure out what the function value will be, you'll get 0 over 0 for your function value. While that's still undefined, it's a trick play because that means, oh, there's a factor on top and bottom that go to 0. Versus my right side, infinite discontinuity, I'm just dividing by 0. The top didn't equal 0. So that's another way. If you have a removable discontinuity, when you plug it into the function, you'll have 0 over 0. Okay, step 2. We want to find the limit of my function as x goes to -2. So your limit, you use your simplified function, aka the one where we already crossed out the factors. So I have 1 over x plus 2. So I'm plugging in -2 for x. All right, so we're using this down here. Plug in -2, and I have 1 over 0. So that's also undefined. Since both of them are undefined, we know that this is not continuous and it will be infinite.
So when they're the same, it's infinite?
So if they're both, sorry, this do not exist. If they're both, if you don't have a function value there and you don't have a limit, it's going to be infinite. The only way you'll have a jump discontinuity is if I give you a piecewise function. Like, you're not going to have a jump unless that's the bare minimum. You have to have a piecewise function. Okay, so f of -2 is not equal to my limit as x approaches -2 of my function. So this is going to be not continuous and it'll be infinite. So at -2, let's see. So my function is going to roughly look something like this.
But doesn't f of -2 equal limit of x?
F of,
Oh, no, they're
it's not the same thing. Because This is like if I had a jump discontinuity. Oh, from once, you know, if I would have a function that like has a hole here and then has a function up here, a function value right there, although we would have a limit and we would have a function value, they must be the same. That's what I'm trying to show you here. This is why we have the third step. So although you could have a limit and you could have a function value, they have to be the same thing. That's why we have that third step. Okay, and then these, find the zeros. You could just use your calculator. Did I put this on the test? I mean, you have to know how to find it anyway. So this would be more for like the second part of the chapter test.
Points of
Find and classify points of discontinuity.
How do you do that? That's cool.
Well, if I try to factor the top, let's see. I can't easily factor it, but I know there's nothing that cancels, so no removable. This is not a piecewise, so no jump. The only discontinuity I'd have is if x equals 0, because that'd mean I'd divide by 0. And that would be an infinite discontinuity at 0. So if you graph this, you'll see like going to infinity or whatever at x equals 0. End behavior, I feel like we talked about that. And zeros, you can use, like this would be one where you use a calculator. So there's two questions. The first two questions ask about the zeros and x and y intercepts. They're very straightforward in my mind. 3 and 4, domain and range of the graphs.
Wait, so if you divide by
5 and 6 is just like the problem we did right here. 7 and 8, end behavior has to be in like limit notation. 9 and 10, it's like 3 questions where I'm like, find the limits. 3 questions of find the function values. Those are 2 questions. That's the whole test.
So if you divide by 0, it's an infinite.
So you have to be careful because if you're dividing by, notice on the left side here, we're dividing by 0.
Not for that one, the other.
Oh, this one. After I cancel out any factors, because that's the only way you have removable, factors cancel out. Nothing cancels out here, so any of the values that would make my bottom go to 0 would be infinite.
And it's only jump if it's
It has to be a piecewise. Okay, so that's the end of class.